Hello students, welcome you to this session. We studied in the last class how to find domain and range, right? So in today's class I'm going to teach the composition of functions. Already you studied in 10th standard. I'll explain the whole thing. Composition of functions, then how to find inverse of a function. So okay, these are the two major areas we are going to study today. So first let us see what is composition of functions. So if you have two numbers, you can add them, subtract them, right? Different operations. Same way, when you have two functions, composition is one of the operation on functions. Okay, so I'll explain it and how to denote. Suppose there are two functions. F is a function. F is equal to say 2x plus 3, and say g is another function, g of x. And first we take it as say f of x. G of x is 7x square, something like this. Then the composition of two functions we denote like this. F, small circle you write, F composition G. F composition G. If you want to find this, you find F composition G of x. And this we denote it as F of G of x. So that is F of, what is G of x? 7x square. G of x is 7x square. Now, what do you find now? F of 7x square. You have to find F of 7x square. So what do? You know what is F of x? You know how to find F of 7. If they ask F of 7, in F of x, wherever x comes, you put 7. F of k means for x you put k. That's all. Here we want F of something. So in F of x, wherever x comes, you put this something. So that means, what is F of x? 2x plus 3. 2x plus 3. Instead of x, you substitute this value. What value? 7x square. So your answer is 7 2s are 14x square plus 3. Okay, this is F composition G. Now, just to explain how to find G composition F. Already you have studied in 10th standard, just I'm going to revise it. G composition F. That is G of F of x. First F of x, then only we give that function to G. So that is G of, what is F of x? 2x plus 3. Now, put this 2x plus 3 in what? G. But what is G? 7x square. G is what? 7x square. So instead of x, you put the value. What is that? 2x plus 3. Now you know how to do that. Just expand it. A plus b the whole square, expand it. Then you multiply by 7. And in most of the cases, you see both the answers are different. So in general, F composition G is not equal to G composition F. So in general, so rarely in some cases they may be equal. In general, they are not equal. That means composition of functions is not commutative. Composition functions is not commutative. But you know, composition of functions is associative. Composition of functions is associative. So those who study 10th standard state board, it's quite easy only. But if any of you studied in CBSE or some other class, you would have not studied composition of functions, some other boards. So if you need more help in composition of functions, we have uploaded a separate video in composition of function. You watch that, you'll get a clear idea on that also. Okay, but this is enough. What I'm explaining here, that is enough. But if you want further, you can refer that video. Okay. Now straight away go for the sums. Look at this question. F and G are two functions from R to R defined by f of x is 3x minus 4. F of x is 3x minus 4. And G of x is x square plus 3. See, first what they asked, first we want G composition F. So to find G composition F, you find G composition F of x. So that is G of f of x. That is G of f of x. What is f of x? 3x minus 4. Now this value you substitute in G. See, what is G? X square plus 3. What is G? X square plus 3. Instead of x, you write the value. What is that? 3x minus 4. So now a minus b the whole square. Okay, so just you can expand it. It is a square. What is that? 9x square. Minus 2ab. 2 into 3 into 4. Minus 2 3s are 6 4s are 24, right? 24x plus b square. What is b square value? 4 square. It is 16. Then finally that 3. So your answer is 9x square minus 24x plus 19. So this is the value of G composition F. Next they asked to find what? F composition G. So now same method we are going to find F composition G. For that you find F compose G of x. That is F of G of x. That is F of, what is G of x? X square plus 3, right? X square plus 3. Now put this value in what? F. See what is F? F of x is what? 3x minus 4. So 3x minus 4. Instead of x, you put that value. What is that? X square plus 3. Multiply term by term. 3x square plus 3 3s are 9 minus 4. So your answer is 3x square plus 5, right? And you can see the answers are what? They are not equal. Okay, so they didn't ask you to prove they are not commutative, just they asked to find the value, so stop here. So question they can ask, verify commutative property of composition of functions. Then you find both F composition G and G composition F, and you can do that, and they can frame any number of questions here. Some unknown they give, K. They may say find K value so that F compose G equal to G compose F. There are different type of questions, so you can practice that. Now look another question. Given in ordered pair, right? F is a function 1, 2, 1 is related to 2, 3, 4, 2, 2. G is another one, 2, 1, 3, 1, 4, 2. If some functions given, you know, right? Some f of x equal to 2x plus that type we did. Now if they give function like this, so like image, pre-image and all, then how to do this? Listen very carefully, it's a very simple one. So first let us find G composition F. To find G composition F, please listen very carefully, you have to start with F. To find G composition F, you start with what? F. In F, you see what is the first letter? 1. So now I want to find the image of 1 under G composition F. So what do you do now? First you find the image of 1 under F. What's the image of 1 is related to what? 2. 1 is related to 2. So now this 2 you look into G. In G that 2 is related to what? 1. So the overall the answer is 1. Look again. Listen carefully. So I want to find the image of what? 1. Take the first number. Here the first number is 1, right? I want to find the image of 1 under G composition F. So first you start with F, inner function, G composition F. So start with F. In F the first number is what? 1. So I want to find the image of 1. For that 1 is related to 2. 1 is related to 2. Now that 2 you see here. Yes, the 2 is here as the domain of G. That 2 is related to 1. So the overall 1 is related to 1. I'll explain the next one so you can understand better. Now in F we take the second number. What's the second number? 3. So you write 3 here. We want to find the image of 3. Now for that what do you do? No? The 3 is related to which number? 3 is related to 4. Now that 4 you see here. That 4 is here. Yes, that 4 is related to 2. See, 3 is related to 4 and that 4 is related to 2. So that means 3 is related to 2. 3 is related to 4 and that 4 is related to 2. So overall, what can you say? 3 is related to 2. Hope you got better idea now. See one more, even you can say now. What is the third number? The domain 2, right? 2. We want to find the image of 2. So 2 is related to 2 and that 2 is here again. That 2 is related to 1. So it is what? 1. Don't think 1 is missing that. Don't take that one. Okay. So be very careful in this. Okay. So this is G composition F. Now I am going to teach F compose G also. So I will be thorough in that. Okay. Even one sum you learn properly with proper understanding. Then you can answer any question. Just try to understand, that's all. Okay. See. Second we are going to find what? F composition G. F composition G means you start from where? Second function G. You start with G. So now listen, in G, what is the first number? 2. I want to find the image of 2. 2 is related to 1 2 is related to 1. Now we come this side. 2 is related to 1. That 1 is here. Yes, that 1 is related to 2. So the answer is 2, 2. In G, the second number, what's the second number? 3. So take 3. 3 is related to 1, and that 1 you see, yes, same thing again. 1 is related to 2. So here also 2. Take the third number. What's the third number? 4. 4 is related to 2, and that 2 is related to 2, right? So that 2 is your answer. So hope you understood. This is how we have to find F composed in G and G composed in F if the function is given like as an ordered pair. See one more question. F, G given, right? F and G given. What they asked to find? First they asked to find G composition F. So now you know that thoroughly, right? G composition F. So you start with second function. What is the second function here? F, right? So start with F. See, where is F? Yes. What's the first number? 1. 1 is related to 4, and that 4 is related to 1. So 1 is related to 1. Take the second number. What is the second number? 2. So write here 2 immediately. So 2's image we are going to find, right? The 2 is related to 5, and that 5 is related to 2. So 2, 2. Then 3. Third number is 3. 3 is related to 5. 3 is related to 5, and that 5 is related to 2. So it is 2. 3, 2. So this is G composition F. Second part, they didn't ask you to find. What is what they asked? Can you find F composed G? So be very careful. Something should be there, right? That's why they are asking like this. Can you find F composed G? Let us see. We'll try that. Okay, F composed G, we try to do that. So you start with G, right? In G, what's the first number? 4. The first number is 4. See that 4 is related to which number? 4 is related to 1, right? 4 is related to 1. So you have to see that 1 here. 4 is related to 1, and that 1 is related to 4. So 4, 4. Take the second number, 5, right? So you write 5 here. 5 is related to 2, and 2, yes, it is here. 2 is related to 5. Take the third one, 6. So write here 6. 6 is related to 4, and that 4, where is 4? Don't take this 4. Here 4 must be some domain. The first place it should be, it is not there. So you cannot find the image of what? 6. The image of 6 does not exist. So can you find F composition G, they asked, right? So what answer you can give? So F composition G, we cannot find F composed G, right? So F composition G is not defined. Reason you give. For the reason is the range of G, because we have to start with G, right? The range of G, you know, what is that? Range means the answer is 1, 2, 4. But, and it must be contained in the domain of what? F. Okay, because for its image we are finding in what? F. But in F we need these elements. So this 1, 2, 4, 1 is there, 2 is there, but 4 is not there, right? So 4 is not there. Which is not contained in, in the domain of F. Domain of F. But because domain of F is 1, 2, 3. 1, 2, okay, but we want 4. 4 is not there, right? So G's range must contain in the domain of the other function F. So it is not satisfied. So you cannot find what? F composition G here. So you know the reason why it is not contained. Okay, now let's go for the next question. So now let us see how to find what is inverse of a function. It's another very simple area. See, suppose they are giving, say, f of x equal to 2x plus 3, something like this. A function is given. The question is find the inverse of the function. I'll tell you the simple method. What do you do now? You take f of x, you take it as y. Y equal to 2x plus 3. From here you find x, that's all. From here you find x. So 2x is equal to y minus 3, or x is equal to y minus 3 by 2. So this is the inverse of f. This is the inverse of f. F inverse is equal to y minus 3 by 2. Since it is a function of y, you write f inverse of y. You write F inverse of y, but we want F inverse of x, right? F inverse of x, very simple. Instead of y, you put what? X. So it is x minus 3 by 2. So this is how you find inverse, basically. Suppose f of x is 2x plus 3, any function. To find inverse, f of x, you take it as y first. Then from that relation, you find x. Find x. Now x is a function of y, and that is the inverse. That is the inverse of f. Since it is a function of y, we are writing f inverse of y, but you can change the variable, right? So therefore, f inverse of x is replace y by x. So this is the basic thing. From here, we are going to study another very important thing. You can expect a 5-mark question in that area. So that is how to find bijection. What is bijection? Already you studied 1, 1 and on 2, right? That we call it as bijection. Invertible. Invertible means inverse exists. If a function is 1, 1 and on 2, then inverse exists. Then inverse to each other, everything related, everything same only. So any question in this one, prove that it is a bijection, prove that the function is invertible, prove that this and these two are inverses to each other. Any question of this type, the method is same. So see the theory part here. F is a function from x to y is said to be invertible if there exists a function g from y to x. F is from x to y, so inverse must be from y to x, right? So that we take it as g. G is from y to x such that g composition f equal to I of x. I of x means identity function of x. It is actually x only. So g composition f is x and g f composition g is y. Okay, that is I of y. I of x and I of y are identity functions on x and y. Then g is called the inverse of f. G is the inverse of f and f is the inverse of g, and it is the g is the inverse of f, so g is denoted as what? F inverse. Okay. And what is bijection? Suppose how to prove it's a bijection. Same method only you are going to do. F is a function from x to y. F is from x to y, it is a bijection. G is its inverse function. Then g composite f, same condition only, right? Then g composite f equal to I of x, that is x, and f composite g is y, that is I of y. Then both f and g are bijection. F is a bijection and g is also bijection, and they are inverses to each other. They are inverses to each other. F inverse is g and g inverse is f. Okay, so I'll tell you now simply I'll tell you just one line. Remember this. F is the function of x, right? G is the function of y. F is the function of x, G is the function of y. To prove what is the condition, F composition G, F composition G. Many students, you have doubt whether you put x or y here. And what answer you get? Identity, but it is x or y, ix or iy. Listen, this is a very simple thing. F composition G, so you see the second one, G. G means it should be y, G of y, G of y. So write here y. And your answer is y. Y means it is I of y. I of y is y only. Okay, this is one condition. Another condition, now first one is F composition G. Now G composition F. G composition F. So F means it is a function of what? X. So outside you should write x. G composition F of x is x. That is ix, identity function of x. That is actually x only. Okay. If these two conditions satisfied, then you can say both F and G are bijection. F is invertible, they are inverses to each other. Any question of this type, this is what you have to prove. This is one method. But for bijection, to prove 1, 1 and on to, we have different method. How can you prove 1, 1? That's a different method, right? F of x equal to f of y implies x equal to y. Then you say, yes, the given function is 1, 1 function. On to, the range and codomain are equal, right? So like that also you can prove. Once you prove that too, you say, yes, it is the bijection. So there are different methods. I'll try to teach both the methods, okay? But this method is more useful, okay? So prepare well. Now look at this question. F is from R to R is defined by f of x is 2x minus 3. F of x is equal to 2x minus 3. Prove that f is the bijection and find its inverse. F is the bijection. So here see what is given. F of x is 2x minus 3. I said there are two methods. To find inverse, there is one method only. What is it? Fx, you take it as y. From that function, you find x value, and that is the inverse. F inverse y. F inverse x means instead of y, you put x. That's all. That method we are going to do here because finally we want to find the inverse. First, to prove bijection, I'm going to teach the basic method. So we prove 1, then you prove onto, then you say it is a bijection. That method. In another sum, I'll teach you the other method also. Okay. So this is fx. So we start with fx equal to fy, f of x equal to f of y. We have to prove x equal to y, right? F of x equal to f of y. What is f of x? 2x minus 3 equal to f of y means 2y minus 3. So 3 get cancelled, you are getting 2x is equal to 2y, right? Dividing by 2, you are getting x equal to y. That's all. Which implies f is 1 to 1. F of x equal to f of y implies x equal to y. So you can say the function is what? 1 to 1. So second part, what you have to prove? Because it's a bijection, you have to prove 1 and onto, right? So now here, you see the function fx equal to 2x minus 3. For any value of x, there is a y, right? You will when you substitute some x value, or you say fx equal, or you say y equal to 2x minus 3. For some value you give for x, you will get the y value. So same way to get y, so your answer can be any of the real number. So now you know it is 1 to 1 function. So that is not enough. To prove bijective, you have to say onto also. It is onto function only, but because its range is what? R. Range is also R only. So there is no restriction here. So range of f is R, and which is a codomain. Which is the codomain. Range and codomain both are equal, R to R. Okay, codomain is also R only. So both the conditions satisfied, therefore, what can you say? F is a bijection. Okay, this is one method. So main work is 1. To prove onto, just some writing work only. So the steps you remember. Okay. So first part is over. Now find the inverse. So we start with f of x equal to 2x minus 3. F of x equal to 2x minus 3. So this is to find inverse. So earlier I said no, how to find inverse. What do you do? First f of x, instead of f of x you take it as what? Y. So y equal to, let y equal to 2x minus 3. From this expression you find x value, that's all. So take minus 3 to the other side. So 2x is equal to y plus 3. 2x is equal to y plus 3, or x is equal to y plus 3 by 2. So this is the inverse of the function, right? So f inverse is y plus 3 by 2. But it is a function of y. So if you want, you write f inverse of y, or straight away, instead of y, you put x and you write it as what? F inverse of x. Okay. So f inverse of x is x plus 3. Instead of y, you put x, that's all. 2. So this is the inverse of the function. Okay. So hope you understood this. Now let's go for the next question. Another question of the same type only. Listen, if f from R to R is defined by f of x equal to 3x minus 5. What's the question? Prove that f is a bijection. Like previous question you can do. F of x equal to f of y, you prove x equal to y. Then codomain and range are same. Both are R here. So it is a bijection. But I am going to teach the other proof. So both you will be thorough with that. And one more thing they asked, and find the inverse. So to prove the other method, you need G. F and G. Then F composition G, G composition F. In both the cases, you have to get the identity. Then you say it is a bijection, one is inverse of the another one, everything will be proved in a single step, right? So first you find the inverse, and that inverse you take it as G. F inverse x, you take it as what? G. Okay. So let us find inverse. For that, what you do? You take that f of x as y. Just now we did no same method, 3x minus 5. From here you find x value. So 3x is equal to y plus 5, or x is equal to y plus 5 by 3. So now I'm going to write straight away f inverse of what? X. F inverse of x means, so this is the answer, right? But instead of y you write x. So what you write? X plus 5 by 3. X plus 5 by 3. Okay. And okay, this is find the inverse. So this is the answer for that part. find its inverse. F inverse is F inverse X. Okay, so this is the answer for one part, but finally write it again. Now prove F is the bijection. To prove F is the bijection, F is from R to R, right? So we need another function G. So G is also from R to R, and that G of Y we take. F of X, G of Y. So that is the inverse function. This is the inverse function. This function only we take it as what? G. But G of Y, so variable you change. Instead of X you put Y. Y plus 5 by 3. So you know F of X and G of X. What is F of X? 3x minus 5. G of Y is Y plus 5 by 3. It's very important. F is a function of X. G is a function of Y. Now to prove it's a bijection or invertible, or to prove they are inverses to each other. So what you do here, two things you have to prove. One is F composition G of, what you write? Here G is there, no? G of X, F of Y, like that, sorry, F of X and G of Y. So since G is here, you write here Y. And what answer you are supposed to get? You are supposed to get Y as your answer, and that is I of Y. Okay, identity of Y. Let us see how to prove this composition of functions we studied, right? So you can write it as F of G of Y. That is F of, what is G of Y? It is here, Y plus 5 by 3. Put this value in F. Put this value in F. See what is F? 3x minus 5. 3x minus 5. What is X? Y plus 5 by 3. The 3 cancel. You are getting Y plus 5 minus 5. Minus 5 plus 5 cancel. You are getting Y as your answer. This is one, F composition G. One more you have to prove. What do you have to prove? G composition F. G composition F of what you write? See the second one, F. F of X. So write here X here. And what answer you are supposed to get? X only. So what you write here X. So you are supposed to get X. And that is same as what? I of X. So now please listen here. Again composition of function G of F of X. That is G of F of X. See what is F of X? 3x minus 5, right? 3x minus 5. 3x minus 5. Now put this value in G. Put this value in G. So see what is G of X? Y plus 5 by 3. Y plus 5 by 3. Y plus 5 by 3. Instead of Y you write 3x minus 5. So that is 3x minus 5 plus 5 by 3. Plus 5 minus 5 cancel. You are getting 3x by 3. 3 cancel. So you are getting X as your answer. And that is same as what? I of X. So both you proved, no? So what you prove now? F composition G. F composition G is equal to I of F composition G. G of Y. F of X. Like that you remember. G of Y. So IY. And G composition F equal to I of X. Second one is F. So Fx. F of X. So both conditions satisfied. So you can say F and G are bijections. Both are bijections and they are inverses to each other. Whatever they ask, this is what you have to do. They are inverses to each other, and also F inverse of X. F inverse of X, that is G. Albert already written, right? F inverse of X is X plus 5 by 3. So this type question you practice, it's very important. So domain important, range important, and this is another important thing. And there are so many other questions, around 20 questions given, but there are very simple questions are there that we will discuss in the last one. Okay. Okay, now we start from the first question. What are the things we left out? We go quickly. Okay, some of the major area we finished. Now other things are very simple thing, just very simple concepts only. Okay, listen here. Suppose that 120 students studying in 4 sections. You imagine your school. There are 120 students studying in 4 sections. Suppose you have A section, B section, C section, D section. 4 sections are there. Totally how many students are there? 120 students. Okay, so A is, there are 2 sets we take. Totally there are 120 students and there are 4 sections. Okay. Now what else? Let A denote set of students. So A is denote set of students and B denote the sections. So these are the sections. Okay. Define a function, a relation from A to B as X related to Y. X is related to Y. XY belongs to R. When there is a condition. What's the condition? X is related to Y. If the student X belongs to Y. Student X. So the first one is student. Student X belongs to the section. Please listen here. Student, totally how many students are there? 120 students. 1, 2, 3, 4, etc. 120 students are there. Sections, how many sections? A, B, C, D. Okay. So from this is A, this is B. Domain, codomain. Now, is this relation a function? So is it a function? A to B, is it a function? So simple arrow diagram, right? Every element must be related to one element and it must be related to only one element, right? So when you put arrow, one arrow must start from every number of the domain, every element of the domain, and only one arrow must start, right? You take the first student, okay, take one 11th standard student, call him and ask him which section you belong to. He will say, I belong to C section or A section, some section, okay? Yes. He won't say, I belong to A and B. Nobody will be there, right? So belong to two sections. No. Every student, ask the second, you call some student, second student, which section? He will say some section, right? So every student says some section. Every student belongs to some section. Nobody is there left out. So they cannot be in two sections. So every element of the domain has image, only one image. So it is a function. A to B, it is a function. Now see, what can you say about the inverse? Inverse is a function or not? B to A. So now you take section here, A, B, C, D. Section. And the students. So this is B and this is A. Now we have to see B to A. Students 1, 2, 3, 4, 5, 6. Now we have to check whether it is a function. So how many students are there? 120 students are there. So okay. A section, you take one student. For A section, you cannot take one more student, then it is not a function, right? So A is related to 1. Okay. Then B, you take one student. So one section, only one student, right? Social distancing. Okay. For C, you take one student. Okay. Because for function it is compulsory, right? Every element must be related to one element, only one element. Now for D, there are 120 students. So you have to accommodate 117 students there, right? So it is not possible. So you know it is not a function. It is not a function. Okay. So but you have to write it properly. Listen, hope you understood that. Once you understood is some writing work. Listen, this is how you write for the exam. A stands for set of 120 students. B stands for set of 4 students. X related to Y. X comma Y. If the condition student X is in section Y. First part, every student, A to B, check whether it is a function or not. Every student belongs to one and only section. Already explained. Take one student, he belongs to one section, right? He cannot say I'm in two sections, no. And that means every element of A has only one image, so it is a function. But the second case, each section you allot one student, then at least for some section you have to allot more students, right? More than one. So that section has more images. So it is not a function. At least one section will have more than one student. Therefore, inverse relation is not a function. Okay, just you have to understand that's all. Next, you see the second question. It's a very simple one. You have 10 standard sum only. So f of x, 1, 2, 3, 4, 5 values are there for f of x. In 10 standard, this is one of the very important, very simple thing, right? Okay. If in the question paper, if this type question appears, you'll be very happy, right? What they asked, find the value of f at -4, 1, -2, 7, 0. 25 subdivisions there, okay? So first one we use only if x lies between -infinity to -3. Up to -3 is included, right? So that means -3, -4, -5, etc. up to -infinity. Second function we use between minus 3 to minus 2. That means, but minus 3 is not included, minus 2 also not included. Then what you can take, right? You cannot take anything. What about the third one? Third one is minus 2 less than or equal to x less than 1. So you can't take 1, 0 onwards, right? You can take like that. Okay, hope you know that one. Then x minus x square, that is 1 to 7. 1 is included, 7 is not included. So 1 to 6. Okay. In other cases, it is otherwise. So after 7, even for 7, 7, 8, 9 and all, you have to take the value as what? 0. Okay, let us find one by one. First, they asked to find f of minus 4. See, minus 4 lies in the first one, right? Minus infinity to minus 3. Because minus 3, then only minus 4, right? Minus 5 up to minus infinity. For all these things, the first function. So minus x value minus 4 plus 4. So minus minus plus. So 4 plus 4, the answer is 8. Second one, f of 1. 1 lies where 1 is here, right? 1 less than or equal to x. Yes, 1 is here. So you use this only. For x, you put 1. 1 minus 1 square. 1 minus 1, it is equal to 0. Third one is f of minus 2. F of minus 2. Minus 2 lies here. So in one case, less than only, right? So here they asked to find minus 2. Minus 2 is here. Less than or equal to, right? So that function you use x square minus x. X square minus 2 square minus x. Instead of x, you put minus 2. Minus 2 square is 4. Minus minus is what? Plus 2. So the answer is 6. Next, they asked to find 7, right? So find f of 7. Listen, 7 is where? So here you have a 7, but it is not there. X less than 7, not less than or equal to, right? So you can't take that one. So it comes in otherwise. So in all other cases, the f of x value they given us what? 0. So since f of 7 is not in any of the first 4 cases, so your answer is what? 0 only. And one more they asked, f of 0 they asked, right? F of 0. 0 lies where? Minus 2 to 1, right? Here only 0. So x square minus x, this you use. Instead of x, you put 0. So 0 square minus 0. So your answer is what? 0. So it's a very simple thing. This is third question, is similar question only. You can do it of your own, right? Okay, now see the next question. State whether the following relations are function or not. State whether the following relations are function or not. So you know every element must have image, only one image, that's all. If it is a function, check for one-to-oneness and onto-ness. If it is not a function, give the reason, right? Okay, A is ABC. So the easiest one, arrow diagram, right? ABC. A to A, so here also what? ABC only, but separately do that. But here when you write in a proper way. See the first one, A is related to C. Second one, B is related to C. Third one, C is related to B. Is it a function? Every element of the domain A, B, C have images. And every element has only one image, right? A has one image, B one image, C one. So it is a function. So the first one of a subdivision, it is a function. Reason you can say, since every element of A have only one image. So now some more, right? If it is a function, check for one-to-oneness and onto. So it is one or many one. It is not one, right? Because many elements are related to one element, right? So A not equal to B, but f of A equal to f of B. Why you know? F of A, what is the image of A? It is C. F of A is C. F of B, B's image also what? C. They are equal. You take two two elements which are not equal. A and B are not equal, but they have the same image. So different elements have same image. Different image means okay, it is 1, 1. But here different element have the same image, so it is not 1, 1. So it is not 1, 1. Onto or not, it is not onto also, right? What's the reason? The element A has no pre-image, right? A has no pre-image. Also, the element A has no pre-image, therefore it is not onto also. It is not 1, 1. Also, it is not onto. Onto, another way, what can you say? Codomain and range are same. Here the codomain is A, B, C, but range is only B and C, right? So A is not there. So hope you understood this. So there is one more subdivision. We'll do that also. Look at this. State whether the following functions are relational. Same thing only. So here x is given. X is x, y, z. The function is x to x only. Okay, so the first one is x. Second one is also x. The elements are x, y, z. So what is the first ordered pair? X, y. Next one is x, z. Now itself you know it is not a function, right? Why? The element x has two images, so it is not a function. And what's the next one? They given x, z, and the last one is what? Zx. Zx. And one more reason, the element y has no image, right? Every element must have, in a domain, every element must have image. Here y has no image, so it is not a function. And every element must have only one image. Here x has two images, so it is not a function. There are two reasons. You can give any one reason you can write for the exam. Okay, it is not a function. Don't stop here. If it is not a function, state why, right? Reason you should give. Reason. Even one reason is enough, but you write both now. X has two images. Another reason, this is one reason. Another reason, if you want, you can say y has no image. Y has no image. Okay, hope you understood. Little lengthy one, but I want to help every sum. That's the reason we take more classes. So in the next class, we'll try to work out the sums what I left out.